Now let's look at two multiple choice questions. Both are taken from past exams. So first one, which graph shows the relationship between the pressure and volume? So pressure and volume of a sample of gas at a constant temperature. So we know that the gas equation, PV equals to nRT. In this case, T is constant, and they say it's one sample of gas. That basically is saying that N is also a constant. If that's the case, then on the right-hand side of the equation, we have basically three constants multiplied together because R is the gas constant, okay? Which means that PV actually equals to a set number. Now, what will be the graphical relationship between P and V? We know that we can write P as, because we have pressure here, all on the y-axis. Okay, so P would equal to a particular constant, let's say K over V. And from mass, we know that the graph that portrays this kind of relationship should be B. Now, let's have a look at question 22. The two containers are connected by a valve. What is the total pressure? Total pressure, so P total, after the valve is opened and the two gas samples are allowed to mix at a constant temperature. So basically the idea is that overall temperature remains the same. Before mixing, we have P1, V1, given by the diagram, and we also have P2, V2. Okay, and after mixing, we will have a P total. So that's the whole process. P1 and P2 essentially determines N1, right? Because temperature is constant before and after mixing. So similarly, we also have N2 RT. If we are to work out P total, then P total should equal to N total times RT divided by V total. Now, V total is easy because before and after mixing, all we need to do is we put V1 plus V2, and we already have both volumes, right? So what is N total then? What is N total after mixing? And we actually, the number of molecules in total after mixing essentially equals to the number of molecules, gas molecules, added together before mixing, right? Although volumes are different and therefore pressures are different in container and container 2 before mixing, but overall gas particles before and after the valves opens remain the same. They're still in the entire container space. So all we need to do is put N1 and N2 together. There we have our N total. So N total times RT should equals to N1 plus N2 times RT, which is N1 RT plus N2 RT. And if we could substitute the values that we do know, it equals to P1 V1 plus P2 V2. So here we have our final calculation equation, P1 V1 plus P2 V2 over V1 plus V2. Now, given that this is a paper 1 question, so we don't have calculator, the numbers are deliberately made easy for us to do this kind of simple calculation. Okay, so we have 4 times 2 times 10 to the power 5 plus 2 times 3 times 10 to the power 5 divided by V1 plus V2, which is 2 plus 4. Okay, essentially our pressure should be 10 to the power 5. As we can see that all our options have 10 to the power 5. We're on the right track. And then the number that we are multiplying is 8 plus 6 over 6. Okay, so that's 14 over 6, which is 7 over 3. 7 over 3, that's not 2.5 yet, it's actually 2.3. Okay, 0.3 times 10 to the power 5. So B is our correct answer.